How do we divide rationals? Invert and multiply. That's probably one of the easiest patterns. There is another way of dividing fractions, and that's if they have a common denominator. If they have a common denominator, I can simply divide the numerators. But unless you're given a common denominator, I'm not sure I'd go through the work of making common denominators to only invert or to have a simplifying method. So which, do we invert both fractions? The second fraction. So we invert the second fraction, and then we multiply. So we can look at trying to cross out common factors if that should exist. So 14 and 10 can each be divided by 2, which would give me 5 and 7. So that when I multiplied these, 7 times 7 would give me 49, and 5 times 3 would give me 15. And then I just do a very quick double check to make sure that 49 and 15 do not have any common factors, which they don't, so then that would be left in its simplest form. Again, I don't have to rewrite these as mixed numbers. I can leave them as improper fractions. So when I look at B, what I would look at doing would be to invert and multiply within these two. So the 9 over 10 would become 10 ninths, and then 1/20. And then I can look at canceling out. So what two numbers that could I pick to have common factors? And what could I divide 6 and 9 by? So then that would leave me with 2 and 3. What else could I pick?
10 and 20.
Okay, and when I divide 10 and 20, I get 1 and 2. And when you do that, notice I now have a 2 and a 2. So I can cancel the factors of the factor. So on the top, what am I left with? That would be a 1. So I have 1s all across the top. And then on the bottom, 5 times 3 times 1, 15. Okay. The difference between B and C is the introduction of brackets, which means order of operations. So my first step would be to do what's inside the brackets. There is no common factor between the tops and the bottoms, which means I would multiply straight across, and I would get 9 over 200. And then I can do the invert and multiply. So 6 over 5 times 200 over 9. And then again, we look at our common factors. So 6 and 9 can both be divided by 3. And 205 can both be divided by what? 5. So 5 divided by 5 would give me 1. And 200 divided by 5 would give me 40. So when I multiply straight across, 2 times 40 would give me 80. And 1 times 3? 3. So we start off with our rational numbers, and then we look at monomials, and then we will look at the division of binomials and trinomials of more rational type expressions. When we have rational expressions, they're rational because we've got this introduction of variables, so we now have non-permissible values. So class example number 2 tells us not to worry about the non-permissible values, the restrictions, but we are going to look at them anyways. So if I look at A, to write this out as a multiplication statement, I invert and multiply. And then we look at what can we cancel out. So do I have any common factors with 16? So they can divide them both by 16, so I'm left with a 1 and a 2. What about 15 and 9?
3.
So then I'd have 5 and 3. And then I can start looking at my variables. I have a on the top and an a squared on the bottom, so one of the a's would cancel out, and the same thing with the b's. One of the b's would cancel out. So if I look across the top, what I'm left with is I've got a 1, this would be times 1, I canceled out a, 5 and another 1, so 5 is what would be on the top. And then on the bottom, 3 times 2, and then a and b. So then when I look at b, the only thing that needs to be dealt with is, I promised we'd go back to non-permissibles. So when I'm looking at my non-permissible values, I have to look at my 2 denominators that were right here, which would be that b can't equal 0. But I also need to consider the one that was up here, because when I invert and multiply, that becomes my new denominator. And that's what we'll spell out below. So we'll go through that a little bit more in depth. So if I look at b now, at negative 5xy cubed divided by 7xz cubed, 2z over 15x, and then negative 21z to the power 4 over 10x squared y squared. So what could you cancel out? The negative 5 and the 15, so I'd have 1 and 3. What else can I cancel out? 21 and 7. So it'd be 1 and my negative 3. 2 and 10, so I'd have 1 and 5. And I also have a factor of a factor. So I have the 3 on the top and the 3 on the bottom that can then also get canceled out. And then I can look at my variables. So x on the top and x on the bottom would cancel each other out. I have a y cubed on the top and a y squared on the bottom. So in a sense, it's like canceling out 2 of the y's. Z4 on the top and z cubed on the bottom would cancel out 3 of the z's. So if I start looking, and it does start to look like a little bit of a jumbled mess because you've got a whole bunch of things that are being crossed out. But I've got a negative and a negative, so I now have a positive 1. I have a y, a z, and another z. So I'd have yz squared. And then on the bottom, all of this was canceled out, the 7xz cubed. Of the 15x, the only thing that remains is x. And then here I had 5x squared. So if I multiply the x with the 5x squared, I get 5x cubed. And again, when I start looking at my non-permissible values, I have all the denominators in the original statement, plus this part up here. So that's what's in this next one is just, if we look at rational expressions, a over b, the non-permissible value would be that b can't be equal to 0. And if I have the expression c over d, I have that d can't be equal to 0. But then when I simplify, I invert and multiply, I now have d over c, which introduces a third non-permissible value in that c can't be equal to 0. And that's really the biggest difference between the multiplying questions and the dividing questions, is that D can't be equal, or sorry, is that C itself can't be equal to 0. So it says state the restrictions on the variables in class example number 2. So we have this part in here. B squared can't be equal to 0, which means B can't equal 0. That's one of my restrictions. When I look at this denominator, I also have a B. I've already taken care of it. And then I have to look towards the top. A squared can't equal 0, which means A can't equal 0. So A and B not equaling 0 become my restrictions. So what would be my restrictions for B? X can't equal 0, which takes care of this, and it also takes care of the x that's in the 7x z cubed.
Z cubed can be equal.
So if z cubed can't be equal to 0, that means z itself can't equal 0. And does that work for the z squared? Yeah. And do I have any other non-permissible values?
Y can't equal 0.
And that's from this part up in here. So y itself also can't equal 0. So let's look at 4a. Trying to think of how best to start talking through it. If I start by rewriting, change this to a multiplication. Now I have a multiplication question which I know how to use from before. Whether you want to do your restrictions on the variable at the beginning or at the end is entirely up to you. Whatever is going to help you make sense of it. If I look at doing it right now, I can look at these three denominators. Or sorry, not three, I guess 2 denominators. What are my non-restriction or non-permissible values in the first denominator? What can't x equal?
2
And in the second denominator, what can't x equal? 0. I already have the -3. And then when I flip it, I now have a new denominator in which x can't equal -1. Okay. So then I can cancel out my common factors. And what would that leave me with as a denominator? Or sorry, as a numerator? X. And my denominator would be which I would leave in factored form. When we take a look at B, and you look at 4x plus 12, what do you notice? It's in fraction form, which means I'm going to be, in a sense, dividing this expression by that expression. So then that's where I'm going to do the invert and multiply. So what do you notice about 4x plus 12?
Factor of 4 out of it.
So if I factor out of 4, what am I left with?
X plus 3.
Right? What about the 3x plus 12? Factor out of 3. And what does that leave me with?
X plus 4.
And I'm going to rewrite this as a multiplication right away instead of having to take that extra step because I want to save lead. This denominator would now move up into the numerator spot. And And then when I take a look at 3x squared plus 9x, factor out a 3x, and what would I be left with?
X plus 3.
So what are my non-permissible values? What can't x equal? So start with this denominator. -4. And then we had, that's the same that I had in this denominator here. And now I have this new denominator. What can't x equal there? 0 and -3. So cross out my common factors, an x plus 3 and an x plus 3, an x plus 4 and an x plus 4. So my final numerator is 4 times x plus 4. And my denominator would be 3 times 3x, which would give me 9x. So we have 3 more examples left, and they just get progressively a little bit harder each time. But the method is still the same. We just look at different types of expressions and review how to factor them. Do you have a question, Rachel?
No.
So when we're looking at these questions, we have to factor first. So if I look at 4x squared minus 12x, what can I factor out?
4x.
And what would I be left with? X minus 3. And what do I notice about x squared minus 9? And when I factor the difference of squares, I get
X plus 3x.
okay. Again, I'm going to change this around and make it a multiplication right from the first step. So that means that this denominator, or this numerator, 7x cubed plus 7x squared is going to become the denominator. Can I factor anything out?
7x cubed squared.
7x squared, which would leave me with x plus 1. And x squared plus 4x plus 3. So what are my non-permissible values? What can't x equal? Okay. And 0. And that takes care of the denominators here, the denominator here, and then the denominator that became the numerator. Cancel out my common factors. I also have an x that can cancel out with this x squared. So by the time I'm done canceling everything out, I have 4 over 7x. Okay, so if we take a look at B, there's a lot going on in this one because I have to simplify this first. So before I can do my division or my multiplication. So what should we do to start off with? Where do you want to start?
Can factor first.
Okay, so what would you factor first, Rachel?
I factor 11.
The 11m, which would leave me with
M squared minus 1.
okay. And then the 2m squared minus m minus 3. We can do that one by sight because I've got those nice prime numbers. the only way I can get a 2m squared is 2m times m. The only way I'm going to get a 3 is a 3 times 1. I just need to know where do I put the 3 and where do I put the 1.
2m minus 3m plus 1.
Because then when I do my inside and outside, I've got a 2 minus 3, which is my negative m. Okay, and then I'm going to multiply that by 2m plus 3 over m minus 1. While we're doing all this, maybe we could factor this at the same time. So what can I factor out of the 20m squared and the 30m? Which would leave me with
2m plus 3.
And what do you notice about the bottom? It's a difference of squares, and what else about it?
It's written on descending order.
Yeah, it's in ascending order. So how can I make this into descending order? Factor out a negative 1, and then I get a 4m squared minus 9. Because everything else is written in descending order, it makes sense to take the things that aren't and rewrite them as descending order. Have I factored everything that I could possibly factor?
No, because it's still difference of squares.
So I still have a difference of squares here
And on.
and up top. Okay, good. So, it's a good thing that the other question didn't take as much room. So I have 10m times 2m plus 3 over what? Negative 1 times
2m plus 3 2m minus
and then I factor out my m squared minus 1 to be m plus 1 and m minus 1. Over 2m minus 3 and m plus 1 times 2m plus 3 over m minus 1. Now that I have everything factored, this would be a good time to look at my non-permissible values. What can't m equal? So I start off by looking at my denominators. In 2m plus 3, what can't m equal? And then in the 2m minus 3, it would be a, so I'd have plus minus 3 halves. That's there. What about m plus 1? Negative 1. And then I have a positive 1. However, this entire thing gets divided, which means if any of these 4 enter or became 0, I would have a division by 0 and I can't have it. So now I have to look at the top here. I have the negative and the positive 1. I need a 0. And then I have the negative 3 halves. So now I start canceling out in places that I can. I can cancel this out because it's outside the brackets. When I look at inside the brackets, m plus 1, m plus 1, m minus 1, m minus 1. So now I can rewrite this as my multiplication. 10m. And at this point, I can actually just take 10 divided by negative 1, and let's make this a negative 10. Over 2m minus 3 times, so the stuff that was on the top is going to move to the bottom, which would be my 11m times 2m plus 3. And then 2m minus 3 would be on the top. factors that I can cancel out?
2 and minus 3.
And the m's. So then on the top I have negative 10. And on the bottom I have 2m plus 3. And then all of these restrictions.
Would it be 11 times 2?
Yes, it would be. Class example number 6, I'm going to do with you, but I'm not going to give you a question like this to do for me. Because this is a big question. Because first of all, I have to actually add and subtract, and then I have to divide. So to add and subtract, because I need to simplify the top, and I need to simplify the bottom before I can divide the two. So simplifying the top means common denominators. What's my common denominator for a and 2a plus 1? It's multiplying them together. So what I get is a times 2a plus 1, which means I multiply the 10 by 2a plus 1, and I can multiply the 12 by a. And then I divide that by the denominator, which was this 5 over a plus 4. So common denominator would be a. So 5 would stay as it is, and the 4 I'd have to multiply by a. So at this point, I can almost look at what my restrictions would be. A can't equal 0. A can't equal a negative 1/2. A can't equal 0 here. And then up here, a can't equal negative 5/4. So I now have 20a plus 10 minus 12a over a times 2a plus 1 times a over, and I'm going to rewrite this as 4a plus 5. So if I simplify the top, 20a minus 12a, so I get 8a minus 10, or plus 10, over a times 2a plus 1 times a over 4a plus 5. What could I do next?
You can factor out a 2 from the 8a plus 10.
And when I take out a 2 from the 8a plus 10, I'm left with
4a plus 5.
and everything else is in its factored form. Now that I have everything completely factored, I can cross out my common factors. So a crosses out with a, and 4a plus 5 crosses out with 4a plus 5. And I get 2 over 2a plus 1. So the extra step in the question is I had to simplify the top and simplify the bottom before I could proceed. I just have to make sure I didn't give you a question like that when I wrote them down. Okay, so questions.
Wait, you guys were doing
Yesterday.
1A, 2B, 3B, 5, 7D, 9 and 10.